All right, folks, here we go. So we left off with the quadratic formula on this one. So x equals negative b plus or minus the square root of b squared. Don't forget your parentheses. Minus 417 all over 2 times 1. So, folks, what I know from the final and from the test we did over quadratics, for some of us, simplifying the quadratic formula is still a bit sketchy. So, taking it from the top, we start by simplifying under the radical with the discriminant. So, typing this turkey into my calculator, we're going to have negative 5 in parentheses squared. Arrow over to escape the exponent, minus 4 times 1 times 7. And that gives us negative 3. So we get positive 5 plus or minus the square root of negative 3 over 2. Folks, what do I simplify next? The square root. And the only thing I can do is take out the negative as an I. So 3 is not a perfect square, so that's going to have to stay underneath the radical. So x equals 5 plus or minus I rad 3 over 2. Now from here, we still need to do division distribution, even though it doesn't actually lead to any simplifying for us, because for complex numbers, we got to have the real part separated from the imaginary part. So final answer, x equals 5 halves plus or minus I rad 3 over 2. Holy cow. So how many total roots did we find for this one? 4. 0 is 1. That was this real one. 4/5 is 2. That's that real one. And then 5 halves plus I rad 3 over 2 is 3. 5 halves minus I rad 3 over 2 is 4. 4 total solutions. So folks, this problem, this is about as bad as it gets, where we had to use both P over Q values and the quadratic formula. Most of yours are not going to be that bad. Go ahead and turn the page. No, there won't be one that's everything. Actually, folks, we're going to sidebar away from that into the guided practice. No, just kidding. We're going to do one more. On the back of this, I want you to, we're going to use example 4's space, and I want you to cross off that problem. We're going to do a different one. I want you to solve x to the 4th plus x cubed minus 8x squared plus 14x minus 8. X to the 4th plus x to the 3rd minus 8x squared plus 14x minus 8. So let's try to factor it. We can't. So there's 5 terms, and there's no GCF, so we don't have anything in our factoring arsenal to come at this problem. So we look at the degree, and we say the degree is 4, so there's going to need to be 4 roots. Do I need to go straight to P over Q values? What do we do first? We're going to look at the graph and see if we can find any of those roots exactly. So go ahead and type that equation in. X to the 4th plus x to the 3rd minus 8x squared plus 14x. Well, hey, that looks pretty good. How many real roots do I have? 2. What does that tell me about the other 2? Imaginary. And folks, what's awesome about this is those look like they are right on the grid. This one looks like it's at positive 1. Let's go ahead and trace 1. Sweet. 1's one of our roots. And where does it look like our other one is? Negative 4. And as we trace negative 4, we see that that is a root as well. So we've got 2 of the 4 roots. What am I going to do with these 2 so that we can find the imaginary ones? Put them in the box. So does it matter which one we put in the box first? No, if you're dividing by factors, you can put whichever one in the division that you want first. So let's go ahead and 1, 2. I'm just going to draw a quick sketch of the graph so we remember that that's what we did here. So sweet, no P over Q values necessary, liking this so far. So we put 1 in the box. Remember, if you're dividing by a factor or potential factor, you flip the sign. Root in the box, the sign remains. So, we've got 1 for x to the 4th, 1 for x cubed, negative 8 for x squared, 14 for x, negative 8 for the constant. Still checking for placeholders, just like we did earlier in this unit. 1, 1, 2, 2, negative 6, negative 6, positive 8, positive 8. And what is the degree of this new polynomial? 3. So it goes down by 1. So now I have x cubed plus 2x squared minus 6x plus 8. Now, if we wanted to, we could immediately depress it using that negative 4, but what else could we try to do at this point? We could try to factor it. So if I try to do grouping here, I can take an x squared out, which leaves me with x plus 2. And then, if I take a negative 2 out, that is not going to work. So factoring by grouping did not work, but why don't I have to use P over Q values? We've got that negative 4 that we can put in the box as well. So I'm going to put negative 4 in the box, and I'm going to depress this polynomial further. So I'm going to take 1, 2, negative 6, and 8. Negative 4, negative 2, positive 8, 2. Bam, remainder of 0. So what's super awesome about this is because I was able to use both real roots to depress it down to a degree 2 polynomial, we should be able to solve this. Now before you go, I'll try to factor it, we know that we already found the real roots. Am I going to find those imaginary ones by factoring? No. So I'm not even going to waste my time trying. We're going to go straight to doing the quadratic formula. Folks, I'm going to turn you loose on this. Get as far as you can with simplifying under the square root, division distribution, and see if you can get to those final imaginary solutions. So folks, here's where I want you to tune in. Can I take that negative 4 that's under the radical and divide it by 2? No, you cannot divide stuff out of the radical. What I need to do first is simplify that radical. What's the square root of a negative? I. What's the square root of 4? 2. This is all over 2. Division distribution. Folks, is it 0 plus or minus I or 1 plus or minus I? 1 plus or minus I. How many total roots did we find? 4. 1 plus I is 1. 1 minus I is 2. X equals negative 4 is 3. And x equals 1 is 4. We found all 4 roots. So, key thing, folks, is we always try to factor first. We can use our calculator to help us find exact roots and to help guide ourselves when we are looking for those non-exact roots. So we're going to go ahead and jump into the guided practice next. Yeah, go ahead. And we're going to go to page 3. Another one? Yeah.
How did that occur?
So folks, we're going to go ahead and look at the first one. Our degree is 4. So how many roots should we have? 4. Can we factor it? Number 19.
Yeah, we can factor it.
So what's definitely something we can do factoring wise? GCF. So the biggest thing I can divide out of all those, 10 only has factors of 10, 1, 2, and 5. Looks like 2 is going to be the biggest that I can take out of all of them. So we take a 2 out. That leaves me with 5x plus 5x to the 4th plus 33x squared plus 18 equals 0. Can I factor this a little bit further? It's worth a shot, folks. So this has the setup of a fake quadratic. We go 4, 2, constant. So let's give it a shot. 1x squared, 5x squared, 18, 9 and 2. Let's do 6 on the top and 3 on the bottom so that we get 30x squared and 3x squared. Sweet. So that will give me the sum of positive 33x squared, and it also gives me the product of positive 18. So then our factors go straight across. So x squared plus 6 and 5x squared plus 3 equals 0. And the 2. Although for this problem, the 2 is less important because I am trying to find solutions. And my solutions are only going to come from my x factors. So if I have 2 times something equals 0, is 2 ever going to be equal to 0? No, there's no variable with it. So 2 is kind of insignificant. And we said x squared plus 6 equal to 0. And 5x squared plus 3 equal to 0. We subtract the 6. Square root. And x is plus or minus. Is it 6i or I rad 6? I rad 6. The 6 is not a perfect square, so that's going to have to stay underneath that radical. There's 2 roots. And then we subtract the 3. We divide by 5. We have to isolate that squared term first. And then x squared equals negative 3/5. Square root. Ooh, so square root of a fraction, we'll handle that a few units from now. But what do I have to simplify? That negative, you got to bring that out as an I. And I'm going to intentionally make a mistake and say, oh, I appear to be done. How many solutions did I find? 1, 2, 3. What do we need, folks? The plus or minus. Wonderful. I want you to look at 21 next. 21. Can we take a GCF out of everybody? Ooh, we can take a 2 out. Sweet. So I'm going to take a 2 out. That leaves me with x cubed minus 2x. Can I factor that a little bit further?
Just a little bit.
What do you want to do?
Take group.
Grouping. And I'm going to draw that 2 outside of brackets just so I know there's still multiplication happening there. So then x squared, x minus 2. And then what am I going to need to take out of this pair so that I get an exact match with the parentheses? A -5. Excellent. So -5, x minus 2. So then taking that GCF of x minus 2 out of both of those, x minus 2, x squared minus 5 equals 0. Now this is fully factored. So if I have 2 times something equals 0, one of those somethings has to be equal to 0. So either x minus 2 equals 0, or x squared minus 5 equals 0. X equals 2, x squared equals 5, square root, and x equals plus or minus rad 5. How many solutions did we find? 3. And as I look at the degree, that's how many I was aiming for. So 3 roots. Now, folks, notice that on these 2 problems, what we haven't had to do is use P over Q values, amen, use our quadratic formula, or even use our calculator. But, folks, your calculator is still a way we can check ourselves. So we're going to type in this equation, just to make sure I didn't do anything weird. Last hand, x. And if I type in this equation, how many roots should I see? 3. Now, it's kind of tough to tell, but this graph dips down and then comes back up slightly there. What's cool, though, is we can use our trace button to check all 3 of these roots. We trace 2. Yup, that's a root. We can trace positive radical 5 because there's no I with it. So second, your x squared button, type 5 and close up the parentheses. Boom, right on the money, x-intercept. Then negative square root of 5. Also an x-intercept, right on the money as well. So don't forget, folks, your calculator is a checking tool as well as a solving tool. Now, folks, what if I type in this first equation? You don't have to do this, but what would I see? Take a look at our roots. What should I see if I type this in? How many x-intercepts? None. This has imaginary roots, so I should not see it touching the x-axis at all. I don't even see the graph at all, which might be a little bit concerning. If I do zoom fit, we'll see what it shows me. So it's kind of quadratic-y shaped, but it is not going to touch that x-axis at all. So don't forget, even on problems that don't require your calculator, you can still use it to check yourself. All right, folks, so let's go ahead and take a look at 23. Can I factor that? No. No GCF. Can't do grouping. There's too much stuff. Our degree is 4, so we need 4 roots. So what should we do? Calculator. So go ahead and clear out any stuff that's in here. Now I'm going to give you guys 3 minutes to decide on your course of action after you see the graph. 3 minutes on the clock. So, folks, how many roots do we see? So, as I'm looking at this graph, it's like maybe 3, but it does look like it dips down a little bit there. So, it looks like we can see possibly all 4. Which ones do we know exactly?
2.
2 is an exact one, so trace 2. That's exact. What's the other one? -6. So I know 2 of them exactly. So before you panic and go, oh my gosh, am I going to need P over Q values? We should be able to use both of these roots and take it down to a quadratic, which I can then square root, or use the quadratic formula on. So folks, take those x-intercepts and put them in the box. Yeah.
What do you do after subdivision?
Get it all the way down to a quadratic, and then either square root, quadratic formula, or if you get it down to a degree 3 and can factor it, you can do that too.
But if you can't factor the degree 3 to the PAQ?
Then you put the other x-intercept in the box.
Then what?
And then you'll have a quadratic.
1x3 minus 2x2 minus 5x2.
Where did it reset? Oh, you picked it on this. So this is a different one. Try one more time. So I think, folks, can we factor it or no? We can try. So grouping x squared. And then if we take a negative
Yeah, we can.
5 out. Super duper. Now, if you wanted to just put 2 in the box, you could do it that way too.
It's like the simple.
All right, folks. So now it's factored. I have something times something equals 0.
Billiards. 8 ball.
Billiards.
What is billiards?
9 ball.
9 ball.
We can set each of these somethings equal to 0. Now here's what we have to be careful about, folks. How many solutions do I have?
We're supposed to have 4. But we only have 2. 3.
Why isn't there an
But then you gotta do but you can use x equals 2.
So that x equals 2 that we got, this is just showing me that from here, the x minus 2 is a factor. I already knew that that was a solution from up here. So this one was already covered. So this is why maybe when we know 2 exact roots, it's better to just put them both in the box to take it down to a quadratic. So just know that those 2 are the same. That's just showing me, hey, that's a factor of this as well. And my other 2 are positive radical 5 and negative radical 5. Again, if you are unsure, trace square root of 5. Boom, there's a 0. Trace negative square root of 5. There's the other one.
Then where's the 2s? Where's the other 2?
The 2 is
on the 2
That's only 3.
No.
1, 2, 3, 4.
So there's 2, 3.
No. We found this one already from the graph. This is just saying, hey, in case you didn't know, the x minus 2 is a factor if I didn't.
So we used the synthetic division to find x plus or minus square root of 5.
Yes.
Alright.
So if you wanted to, you could have, instead of factoring here, put 2 in the box, and that would have taken it all the way down to a quadratic. All right, folks. I'm going to turn you loose on, let's do 22 first.
Yes, man.
Literally.
Literally.
Oh no.
Thank you so much for that. Oh, fail.
You suck. Alright, I'm stuck.
Well,
What do you do after you
I'm
find
on.
the first thing?
I'm stuck again. What do we do, like, graph?
They don't group, Miss Kyle.
Huh?
What do you do when they can't group?
So they cannot be grouped. So look at the graph. See what you know.
I didn't look at the graph.
Yeah, I didn't look at the graph either.
Now you know to look at the graph.
Well, you should definitely consider a career in music industry.
No, you didn't. Miss Kyle, what happens if we just do guys?
You.
It's negative 0.2. What do we say? Yes. Okay, 2 would be.
Why?
Negative 0.2. Can you do that? Can you just start guessing and
No.
The only problem is when it's
What's the graph look like for this one?
very swoopy.
Anything good? Any exact roots, or are we out of luck?
It could be 0 backwards.
Negative 0.2.
Ooh, yeah, those are all in betweeners. So,
Is that a legit guess?
so it looks like there's 2 between 0 and negative 1, and then another one between 2 and 3. So, do you think we'll be able to find all of those using P over Q values?
Yes.
I do.
No.
Here's the issue. P over Q values are only for rational roots. So something like square root of 5, P over Q values will not help with something like that. It can only help us find potential rational roots. So hopefully we'll be able to find one from here. So P values come from the 2. Q values come from the 5. Got to show this work. P values. Plus or minus 1 and 2. Q values are plus or minus 1 and 5. Hey, is 5 halves a P over Q value?
No.
No, it is just P divided by Q, not Q divided by P. So 1 divided by 1 is 1. 2 divided by 1 is 2. 1 divided by 5 is 1/5, and 2 divided by 5 is 2/5.
I think it's 1/5.
Yes, it is 1/5.
So, folks, how many numbers do we have to try here? I don't need to try those two, but it
I don't have
is worth mentioning that I need to try both the positive and negative versions of 1/5 and 2/5. Well, actually, no, just negative. So if I do negative 1/5, ta-da, we get 0. So the sign is negative, so x equals negative 1/5.
So do 0.5.
So, folks, I got to see this work. If there is no other option and you have to do P over Q values, I'm going to expect to see this work in flying colors with the plus or minus included.
Darn it.
So what are we going to do with negative 1/5?
Plug it into some bags of it.
Put it in the box.
Oh god.
But
I wanna go with billiards.
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 It's really spelled the same as.
It's literally it's about the same as billiards.
So,
With a B.
so why
Imagine
can't
the slice it.
it's not billiards.
It's billiards.
so after we break down this polynomial, what's our new degree?
How do you do it so fast?
It's she's a math
College
teacher.
for it.
Yeah.
What?
How do you
It's
know
my
that
job.
1/5 times 9 is -1?
That's not true at all.
You mean 1/5 times negative 10? The 5 cancels out with the 10, leaving me with negative 2. Negative 2 times negative 1 is 2.
How do you -1?
A negative fifth of 5, the dividing by 5 cancels out the multiplying by 5, and we get negative 1.
Oh.
Cross simplifying.
That's crazy.
So 5x squared minus 10x minus 10 equals 0. What do you want to do first before we do the quadratic formula?
I know.
Yeah.
Factor.
And what are we going to factor?
Factor. Oh, jeez. 5? I thought he said doctor.
Take out a 5. And folks, oops, taking out a GCF, my bad. Taking out a GCF first is always best, even if you have to use the quadratic formula, because it's going to make all of your numbers smaller and all of the simplifying a bit better. So quadratic formula is negative b,
Plus or minus
the square root of b squared minus 4ac all over 2a.
Bro, that was crazy.
There it is. There's the.
So for, say, that's 12.
Oh,
We
the
just did it.
barber shop.
Yeah,
Barber.
we just did our barbershop.
That was beautiful.
But we only sing math songs.
We only sing the quadratic.
All right, folks.
Square root.
What is the square root of 12? Ooh.
There is none.
There is none, but are there any perfect square factors we can take out?
6. Wait, no.
What?
4.
4. So I can break this down into square root of 4, square root of 3. Those are the factors.
Get out of
So then
it.
2 plus or minus 2 rad 3
I did not do my Spanish.
over 2. Division distribution. 1 plus or minus rad 3. And folks, you could check that on your calculator using the trace button.
That's hard. That's tough.
So we'll probably do that last problem as a warm-up tomorrow. You'll take the last homework quiz, and then we'll review.
My Spanish is so dumb.
When's test?
So my grades and I go Friday.
Friday.